So having a look at the style of questions we've looked at so far on this topic on Bernoulli trials, first of all, a definition. So we're looking particularly at questions that have two possible outcomes, where the probability of a success is denoted with P and the probability of a failure is denoted with Q. We've had a look at questions where we have repeated trials of a particular Bernoulli experiment, and the notation that we've used for that is to say we have a Bernoulli trial where we have n repetitions of the trial and the probability of success is P. And if you've got n trials and you're looking particularly at determining the probability of getting a particular number of successful outcomes, so in this case we'll go R successful outcomes, we look at the number of ways of getting our R outcomes multiplied by the probability of a success, R times, and multiplying that with the probability of failure, N minus R times. So that's the questions that we've already looked at. Today we're going to focus just on one particular Bernoulli trial. Perhaps we can think about ways of looking at the mean or expected value of a single trial, which might enable us to predict the expected value over a large number of trials, and then we can look at the variance or at the distribution of those particular results. So let's review what we already know about expected value. Expected value, we look at each of the individual scores and we multiply them by the probability of them occurring, like a weighted mean. So we find each of the scores and we multiply that score by the probability of that score occurring. And we do that for each of the scores in the sample space. So I'm going to use subscript I here to denote we're looking at the score and the probability for the same numbered score. And we look at the sum of those for all the scores. So we're finding the sum from I is equal to 1 to I is equal to n. Now, in order to do those calculations, we've used a table like this previously. So we've got the probabilities of failure and success written in here already, but we don't have any value currently assigned to each of the scores. So let's denote a failure with a value of 0, and let's denote a success, a value of 1. Now we can look at coming up with some way of determining the expected value. Now, hopefully the end result here is quite intuitive to you, but let's have a bit of a closer look. So the score times by the probability of that score occurring. We've got 0 times by Q, and we've got 1 multiplied by P. So the expected value is going to be 0 times Q plus 1 times by P, which gives us P. So if we've got one particular trial occurring and we're looking on average, what's the expected value of that trial, it's going to be equal to the probability of the success. So let's now take that into variance, the distribution of the scores. Well, actually, before we do that, just a notation that you might see. We're looking at a particular Bernoulli trial. So we might assign a value of 0, so an outcome of 0 that has the probability of Q occurring, or 1 minus P. And we'll assign a numerical value of 1 for its success, the probability P of occurring. Right, on to the variance. So we have previously encountered variance, and there were two formulas that we had to be flexible in using one or the other. I'm going to focus just on one of those formulas where we looked at the sum of the squares of the scores multiplied by their respective probabilities, and then subtracting from that the square of the expected value. So back to the squares of the scores and the probabilities. We're looking at the sum here for each of the individual scores. So from I is equal to 1 to I is equal to n. And filling that out into this table, again assigning a failure a numerical value of 0 and a success a numerical value of 1. We could fill in our probabilities. And we could go and find the square of the scores times their probability, 0 squared times Q and 1 squared times P. So now we can go and have a look at the variance. We're going to have the sum of the expected values of the square of the scores, which is the sum of this row. Now I'm just going to denote that, not using that notation. Let's be a bit more efficient. It's the expected value of the x squareds minus the square of the expected value. So here we've got, it's going to be 0 squared times q plus 1 squared times p minus mu squared, where we've got, that's going to give us 1 minus the square of the expected value, which we said was going to be p. Sorry, that's going to be p minus p. Which is 0. Sorry, p minus p squared, my mistake. Let's just fix that up. That really didn't make sense. So the expected value is p. So the square of the expected value is p squared. Now sometimes you'll see that written as p outside of 1 minus p, which this 1 minus p, we should recognise that's the same as q. The variance is equal to p q. Now that's interesting. So we're looking at the variance, which remember is the square of the standard deviation, is equivalent to, for a binomial trial, is equivalent to the product of the probabilities for a success and for a failure. So therefore we can make a generalized statement and say, well, therefore the standard deviation for this particular experiment is going to be the square root of PQ.